Hi everyone, and thank you for tuning in for a presentation on Wearable Reasoner towards enhanced human rationality through a wearable device with an explainable AI assistant. My name is Veldema, and I'm a visitor at the MIT Media Lab, where we have been working on this project for a while now. So we're super excited to talk more about it. So let's begin. We live in a world accelerated by information, overloading us with tremendous volumes of data, impacting our cognitive capabilities. Politicians and marketing companies exploit this by using rhetorical arguments to manipulate public opinion for their own favorable outcomes, often regardless of public interests. A typical example is by presenting persuasive claims without supporting evidence and assuring them to be true. During the 2019 US presidential election campaign, for instance, one rally had 67% of statements not only containing false evidence, but lacking evidence altogether. This is more or less due to our frequent use of cognitive shortcuts when processing information, also known as heuristics. Despite equipping us with a repertoire of fast and efficient rules for decision-making under uncertainty, they also make us and our thinking prone to errors, and contrast with careful analytical thinking, which is controlled and rational, but unfortunately requires a lot of mental effort. This error-prone thinking makes us not only susceptible to manipulation, but even makes us hold something as true, despite it contradicting with fact checks. Based on recent advances in artificial intelligence, we envision the possibility of having an AI assistant as an extended rational reasoning organ that assists the individual in becoming more rational over time by making them aware of biased and fallacious information through just-in-time feedback. In our case, as research has shown that arguments presented as self-evidently true are easily believed, we want to encourage people to be more skeptical and seek or demand evidence before jumping to conclusions. In our paper, we present a proof-of-concept device, Wearable Reasoner, a wearable system capable of identifying whether an argument is stated with evidence or not. Our contributions are 1. The development and implementation of a proof-of-concept software architecture, and 2. Exploration and evaluation of the novel area of enhanced reasoning computation and explainable AI feedback through a closed and controlled environment user study. When the user is in a context where they might be in need of assisted reasoning capabilities, they can initiate the device, so it continuously listens to every utterance, classifies them as supported or unsupported, and provides voice feedback to the user. In this way, the user can be more skeptical and seek or demand evidence before making up their mind. However, we don't want people to simply follow the device. Instead, we want the device to provide them with extra reasoning, which they can choose to utilize if they need to. To do this, we deployed concepts from the field of argumentation mining, which focuses on extracting structured arguments from natural and often unstructured text by quickly identifying major claims and their underlying reasons. A famous example of the capabilities of argumentation mining is IBM's Project Debater, an AI system that can debate humans on complex topics. But rather than focusing on a human versus machine type setting, we instead wanted to explore how we can take the reasoning capabilities of a wearable machine and enhance our own reasoning skills with it. Earlier work on wearable technology for cognitive enhancement includes memory and recall, attention, emotion regulation, sleep, creativity, and more. But to our knowledge, the research community has not yet explored the effects of different types of real-time AI-based feedback on user reasoning. To prevent the AI system from becoming an AI black box, it is important for it to be able to explain how it generates its classifications. For this, explanations based on causal reasoning have been found well accepted. When constructing the underlying algorithm for a device, we used the IBM Debater Claims and Evidence dataset, which contains both labeled claims and evidence for 58 different socially divisive topics, such as immigration, poverty, secular societies, etc. We deployed a random forest classifier with 10 trees in the forest and reached an accuracy of 90.4% for our ensemble model. For the arguments in our user experiment, we extracted argument components from our test and training datasets and constructed a total of 96 new argument variants on 12 different topics, consisting of 48 claims not supported with evidence and 48 claims supported with evidence, equally for and against each topic and with no significant differences in word count and grade level. As feedback modes of our device, the non-explainable AI only states single word classification results from our reasoning algorithm, like supported or unsupported, while the explainable AI states its classifications with explanations, like the claim was X because of Y, based evidence C. To evaluate the effects of this on user reasoning, an empirical experiment with both qualitative and quantitative measures was conducted. Using a verbal statement evaluation task, participants were presented with a series of arguments through an audio speaker while wearing the prototype. Upon hearing each argument, they were asked to evaluate the given argument along 3 dimensions. Level of reasonableness, indicating their perceived argument quality, level of agreement, indicating their opinion leanings, level of willingness to donate for an organization that backs the claim, indicating their decision-making tendency. Overall, participants went through 3 control baseline conditions, interleaved by 2 intervention conditions, with the presentation sequence randomized as sequence 1 or sequence 2. The reasoning algorithm ensemble model of our proof of concept device achieved an accuracy of 63.5% in our user study, which was lower than the computer-based performance of 85.11. Despite this, however, our experiment still showed significant effects of the explainable AI mode on users' judgments. When not assisted by the device, we see no significant difference in user evaluation of reasonableness between arguments with and without evidence. However, when assisted by the explainable AI mode of the Wearable Reasoner, we found that participants evaluated claims with evidence to be significantly more reasonable in argument quality than those without. Furthermore, participants tended to agree with claims with evidence more significantly than those without, indicating an effect of reasonableness onto their personal judgments. When asked whether they would consider making a donation to support organizations that back the argument, they were more likely to donate when claims were supported by evidence than those unsupported. However, this effect was not statistically significant. For user experience, participants reported that the explainable AI mode had been very helpful for them to learn about the quality of the presented arguments, and that it helped them to reflect on their judgments. Some participants found the device valuable as a second opinion, while others missed it when it stopped assisting them, showcasing an integration of the device into their thinking. Lastly, some participants also reported phenomena of cognitive dissonance, as they called it, making them more likely to agree with a given argument when the device labeled it as supported, and to disagree with it when the device labeled it as unsupported, even though they were well aware that themselves might have different opinions. Relying uncritically on the feedback of the machine without learning or internalizing a skill can be problematic. Previous evidence has shown that people tend to believe machine recommendations too easily, for example in the case of music recommendations. To further evaluate this, it would be interesting to test what would happen when the AI makes the wrong classifications, for example by stating that an argument is fallacious when it is really not. Our study was conducted in a highly structured and controlled setting. However, in a natural setting, arguments are more complex, consisting of multiple premises mixed in with a lot of unstructured and non-argumentative utterances. They often happen dialectically between multiple people. Some argumentative utterances are intended to express emotions rather than facts, and some also rely on unstated common sense knowledge, which we might not necessarily need evidence to believe. Since users are often bringing in their own expectations and beliefs about AI systems, it is important to take these into account and aim for calibrated trust throughout interactions over time. So for future work, it would be interesting to generate personalized explanations for each individual based on background knowledge and context. In this paper, we proposed one type of enhanced reasoning device which identifies arguments as being supported or lacking evidence. In future reasoning devices, a broader implementation of different types of logic, deductive, inductive, abductive, or fallacy detection could be leveraged for greater real-life use. So to crudely sum up, our study findings are the following. 1. People are prone to letting poor arguments influence their judgments and decisions, as they cannot easily discriminate those that contain evidence from those that do not. 2. A wearable AI system can enhance users' cognitive capabilities through real-time audio feedback of arguments that they are presented with. 3. People are less likely to simply be influenced by the answers from an AI assistant unless it can explain its process. Lastly, we want to end this presentation with a quote from Plato's Socrates and Apology, which largely inspired our work. Plato was very occupied with the fact that people often asserted things to be true without being justified in doing so. He said, "Although I do not suppose that either of us knows anything really beautiful and good, I am better off than he is, for he knows nothing and think that he knows. I neither know nor think that I know." Thank you.